Okay, hopefully you knew what was coming next. After the product rule is the quotient rule. So sometimes instead of having to deal with two functions being multiplied, what do you do when you have to find the derivative of two functions being divided, right? So the quotient rule is a much more complex than the product rule in terms of being easy peasy to remember. So it's just something you have to commit to your memory, right? So remembering that g of x cannot be 0 because we cannot have a denominator in the 0. I'm going to use the uv definition, right? If the top function is u and the bottom function is v, the derivative of that would be u prime v minus uv prime over v squared. So let's just do some examples to practice that. So here, I'm going to set my u equal to 5x minus 2, and I'm going to set my v equal to x squared plus 1, the top and bottom functions. So then u prime is just 5. V prime becomes 2x. Okay? So now let's use my product rule. So the derivative of this whole function would be, first, u prime v. U prime is 5, v is x squared plus 1, minus u is 5x minus 2, 5x minus 2, times v prime, well that's 2x, all over the original function v squared. Okay, now let's figure out what this thing equals. Can we simplify it all? This becomes 5x squared plus 5. I'm going to deal with this part first. 5x times 2x is 10x squared, and negative 2 times 2x is minus 4x. Okay, and that's all over. I'm just going to leave that x squared plus 1 squared. So I'm just going to say f prime of x is equal to 5x squared minus 10x squared is minus 5x squared. Minus and a minus is plus 4x plus 5 all over x squared plus 1 over squared. So that is the derivative of that function. You're just really plugging and chugging when you have to do with the quotients, okay? So now let's deal with this one. We're going to make u equal to 3 minus 1 over x and v equal to x plus 5. So I'm going to rewrite u as 3 minus x to the negative 1. So then u prime would be, that's 0. When I bring that down, negative 1 times negative is a positive 1. So that's just a 1, and then x to the negative 2. And then v prime would just be 1. The derivative of x is 1. So now let's find the derivative of this quotient. U prime v, u prime times v minus u, I'm going to write it, I guess I'll write it 1 over x. V prime, it's 1. Great, I'm not even going to write that, I'm going to confuse myself. Over v squared, over x plus 5 squared. So can we simplify this? Let's see. You'd end up with x plus 5 over x squared minus 3 plus 1 over x all over x plus 5 squared, right? We could probably do some more to figure this out to get these x's off the denominators, but I'm not going to do that now, right? I don't know. Should I do this? Because remember what this ends up being is yeah. So I've worked it out here if you want to try it. This is just algebra or simplification. When I reworked it to make it a nice function, I got this. Right? So this might be something, if this was a free response, you could leave it like this, and that answer would be valid. Your answer would actually be valid here. You wouldn't have to move anymore. You don't have to simplify on free responses on the AP Calc exam. But what might happen is it's a multiple choice question, and then this is like, oh, this is answer A, and you'd have to know that equals that. So to get that, I made these have a denominator of x squared so that I could combine them, and then I multiplied it by 1 over this whole top part by 1 over x plus 5 squared to simplify it. So you can try that out if you're interested. Okay, 3, final one, tangent x. Why are we doing that? Because I can rewrite this as a quotient, right? That's not f prime of x. F of x is sine x over cosine x. So u would be sine x, v would be cosine x, u prime would be cosine x, right? And v prime would be negative sine x. So then my derivative would be u prime v minus uv prime all over v squared. Okay, so let's see if we can simplify this thing out. This comes out to cosine squared x plus sine squared x all over cosine squared x. Okay, what does cosine squared x plus sine squared x mean? That becomes 1, right? So we're left with 1 over cosine squared of x. What's 1 over cosine squared of x? Secant squared x. So here's our identity, right? Something you can remember if you want to keep this, that the derivative of tangent x is secant squared x. You can add that to your trig identities if you want to remember. All right, that's the quotient rule. See you next time.